Now the next question, explain why alkyl groups act as electron donors when attached to a pi system. Now basically, whenever alkyl group it is attached to a pi system, let me take one example. Now this is CH3, CH double bond CH2. So this alkyl group, it is attached to a pi system, okay? And then why they are behaving like an electron donor? So it is all in all about hyperconjugation. It is only and only because of hyperconjugation. Now let me explain you this in detail, okay, with the example, with the diagram. Now, as you can see, this is the orbital diagram. Now, over here, I can see that the sigma electrons of carbon and hydrogen, it get delocalized. Okay, I'm talking about this carbon. Okay, this is the carbon. And then the hydrogen which is present, this is the carbon. And then we have here hydrogen, right? So this carbon and hydrogen sigma bond, it gets delocalized due to hyperconjugation, right? And the alkyl group, as I can see, it is what? It is directly attached to the unsaturated system, right? So delocalization, it basically happens because of the partial overlapping of sp3s sigma bond. Clear? Because this sp3s bond orbital, okay, it is overlapping with the empty p orbital. This is the empty p orbital. This is the empty p orbital. So it is what? It is overlapping in this case, right? And this type of overlapping, basically, it leads to delocalization, which we can also call it as non-bond resonance. And this non-bond resonance is basically hyperconjugation. And because of it, it makes the molecule more stable. Okay, it makes the molecule more stable. So it is basically because of the overlapping of the sp3s orbital and the empty p orbital. There is what? A shifting of electrons, right? So because of this, the hyperconjugation concept comes into picture. And because of that, CH3 group, it is what? It is behaving like an electron donor. If you look into the hyperconjugatory structure for propene, already I have discussed in the previous lecture. So from that also we can write down the entire structure. Okay, I hope the concept is clear to you. Thank you.